Hello everyone. I welcome to you all in this new online session. I am Chetan Rajoria from the Department of Mechanical Engineering, and in this session, we are going to discuss about the method to find out the resultant of a concurrent coplanar force system. Okay, so let us take a problem. So this is the problem. Forces of 2 kilonewton under root 3 kilonewton, 5 kilonewton under root 3 kilonewton, and 2 kilonewton respectively act at one of the corners of a regular hexagon towards 5 other angular points. Determine the magnitude and direction of the resultant force. So in this question, there are various forces which are actually concurrent forces, and all these forces are acting along the various diagonals of a regular hexagon. So for solving this problem, let us draw a simplified diagram related to this question. So this is the regular hexagon. Let us suppose all the forces are acting at this point A. The other corners of the hexagon are B, C, D, E, and F respectively. So let us take all the forces in the same order as given in the question. So the first force is assumed to be acting along this line AF, and the magnitude of this force is 2 kilonewton. The second force is having the magnitude of under root 3 kilonewtons, and this force is acting towards AE. The next force is 5 kilonewton, and it is acting along this major diagonal AD. In this question, we are assuming that this diagonal is horizontal. The orientation of this hexagon has been taken in such a way that this major diagonal is in horizontal position. So the magnitude of this force is 5 kilonewton. The next force is acting along this diagonal AC. Magnitude is once again under root 3 kilonewtons. And the last force is 2 kilonewton, and it acts along AB. So clearly we can see that all these 5 forces are acting in various diagonal direction, and all these forces are also passing through a single point A. So let us see how to calculate the resultant, means the resultant magnitude as well as its direction, means its angular position. So for solving this type of problems, we need to resolve each and every force along the horizontal and the vertical direction. And for this, we need various angles, the magnitude of various angles. So we know that this is a regular hexagon. So this major diagonal divides this whole angle into 2 equal halves. We know that in any regular hexagon, any interior angle, the magnitude is 120 degrees. So this complete angle FAB is 120 degree. Therefore, according to the geometrical principles, angle FAD becomes 60 degree, and angle DAB is also equal to 60 degree. Now, please consider this triangle A, B, and C. In this triangle ABC, sides AB and BC are equal because these are the two sides of a regular hexagon. Because therefore, these two angles, angle CAB and angle ACB, these two angles should also be same. Now in this triangle, angle B is 120 degrees. Therefore, the sum of remaining two angles should be equal to 180 minus 120, that is 60 degree. And that 60 degree angle is being divided into two halves. So every angle means angle CAB and angle ACB are 30 degree each. So let's mark these angles 30 degrees and 30 degrees. Now we already discussed earlier that this angle DAB is 60 degree. Therefore, the remaining angle DAC should be equal to 60 minus 30, that is 30 degree. Similarly, we can prove that the angles DAE is 30 degree and the angle EAF is also 30 degree. Now, after getting the values of these angles, we can proceed ahead. Now, how to proceed? The steps will be, first of all, we will resolve the forces in the horizontal and vertical direction. Then we will find out the total horizontal, the sum of all the horizontal components. Then we will find out the summation of all the vertical components. And then we will use a final formula to calculate the final resultant of all these 5 forces, as well as their inclination. So let's proceed. First of all, we will find the summation of all the horizontal components of forces. This is written as sigma fx. Sigma stands for summation and fx stands for forces along the horizontal plane, along the horizontal line, sorry. So this is the force 2 kilonewton at an angle of 60 degree with horizontal. Okay, this is the horizontal line we are assuming. We can also say that AD is along the x-axis. So AF is making an angle of 60 degree with the horizontal line. Therefore, the horizontal component of this force will be equal to 2 kilonewton cos 60 degrees, because the component which acts with the angle is always the cos component, and the other resolved part is called the sine component. So this becomes 2 cos 60 degree. Okay, this is 2 cos 60 degree. Now let's consider the next force. The next force is under root 3 kilonewton. Now this force is acting at an angle of 30 degree with the horizontal. Okay, and one more thing is there. The resolved part, the horizontal resolved part of the previous force is acting towards the right hand side. Therefore, we are assuming the right hand side direction as positive. Okay, in this question, we are considering the right hand side directions as positive and left hand side directions as negative, exactly as per the Cartesian coordinate system. So the resolved part, the horizontal resolved part of this force under root 3 kilonewton is also acting along the horizontal line towards the right hand side. So we will also take this resolved part as positive, plus under root 3 kilonewton cos 30 degree. Now let's consider the next force, 5 kilonewton. Now you can see it very clearly that 5 kilonewton is completely horizontal. It's purely horizontal. So actually we should write 5 kilonewton cos 0. And now we know that cos 0 is 1. So we can write it simply as 5. 5. Now the horizontal resolved part of the next force under root 3 kilonewton is once again acts towards the right hand side. So once again plus under root 3, and inclination of this force is again 30 degree, cos 30 degree. And the last force, once again 2 kilonewton, and the inclination with the horizontal is 60 degree. And the resolved part is once again acting along the horizontal right hand side direction, plus 2 kilonewtons cos 60 degree. So this is the total summation of all these 5 the horizontal components of these forces. We can find it out using our calculators, and the values is coming to be 10 kilonewton. You can check your calculators and please check the final value of this expression. It's coming to be 10 kilonewtons. Now we are going to find the summation of vertical component of forces. This is called, it is written as sigma Fy. Now we will consider all the vertical components of these 5 forces. So let's consider the first force, 2 kilonewton. So the vertical component becomes 2 sine 60 degree. Because in the horizontal components calculations, we had taken cos 60. Therefore, now in this case, we will consider sine 60, the second resolved part, 2 sine 60. In the calculation of vertical components, we are considering this sign convention. Upward forces we are taking as positive and downward forces we are taking as negative. So this is the sign convention we are going to follow in writing this expression. So 2 sine 60 degree plus under root 3 sine 30. Okay, it is also going to act in the vertically upward direction. Under root 3 sine 30 degree. Now, please observe this force 5 kilonewton. We already discussed earlier that this is purely horizontal. So what should be the vertical component of this force? The exact answer is 0. Because it's purely horizontal, there is no vertical component of this force. And trigonometrically, we can also prove it. The vertical component of this force will be 5 sine 0 degree. Now, what is sine 0? Sine 0 is 0. So therefore, we need not to write the vertical component of this force because it's 0. Now, let's consider the next force, under root 3 kilonewtons. This force is clearly inclined to the downside. Therefore, the vertical component of this force will act to the vertically downward direction. Okay, like this. Just a minute. The vertical component of this force will act in this way, downside. And we are going to take downside as negative. So, we will write the component of this force like this, minus under root 3 sine 30 degree, because the inclination is 30 degree with the horizontal. Similarly, the vertical component of this force is also going to be downside, vertically downward direction. It's 2 kilonewton sine 60 degree. So clearly, the terms in this expression are cancelling out each other. This term is being cancelled by this one, and this term is being cancelled by this one. Therefore, we can conclude that the summation of all the vertical components of these 5 forces are 0. Now, how to calculate the resultant of all these 5 forces? Total resultant or complete resultant. We can see the summation of horizontal components is 10 kilonewton. The summation of vertical forces is 0. Therefore, we can calculate the resultant in this way. This is the formula to calculate the resultant. Summation of forces along x-axis square plus summation of forces along y-axis square, means sigma fx square plus sigma fy square. Let's put the values. It's 10 square plus 0 square. So this is coming to be 10 kilonewtons. So that is our first answer. Now, the inclination of this force, of these forces, the resultant force, the inclination is calculated using this formula, tan inverse sigma fy upon sigma fx. This is the formula to calculate the inclination of the resultant, tan inverse sigma fy upon sigma fx. Let's put the values. Tan inverse 0 upon tan, that is 0, and tan inverse 0 is 0. So the resultant is completely horizontal. Okay, it's totally horizontal. It is acting at an angle of 0 degree, means along the x-axis. So these are our two answers. So this is the reference for this question.